Okay, here is the key for the 1.3 more practice. This first question, I have set up the equation, and I've also shown the table for this particular story. The details of the story, you have to realize that we started with $125. Then the changing amount is we are saving $20 for each week. And then this is what I tested out, these different weeks. And then we had to pay for a $75 ticket, so that needed to be subtracted from our account, and our goal was to get $500. So we were looking for the number of weeks. Right? If you don't see where the equation comes from, then I have the $125, the 20 times the changing amount, and then the $75 ticket. This one came out to 22.5 weeks. The second one here, I also used a table where got some money for the birthday, $50. Okay, so that was the ending amount in both the table and the equation. The number of shirts that we were looking for, sweatshirts, that was our unknown value. So the story here was we had to take the cost of the shirts and subtract the discount of $7. Notice here there was only one discount, and we didn't know how many shirts. So here, we noticed on the table that 4 shirts is $40.80, but 5 shirts was $52.75, so that was too much. Whenever we solve the equation, we actually get a decimal here, like 4.7, but we don't have enough money to buy that 5th shirt, and the table kind of shows that. So the most sweatshirts we can buy is 4. So that one has to be a whole number. Then the third one here, to the library, we have old books, or books that we already have. That's happening in this story. We're adding on 20 books every year. We need to know when we're going to reach a total of 1,500. So notice every time when I set up these tables, I have put what value, what's the name of what we're missing. Here, the arithmetic that ties the story together, and then here the ending amount, the goal, where we're trying to get to. So again, our 1,250 books, we're adding 20 every year, trying to reach a goal of 1,500 books, our ending amount, and that came to 12.5 years. So notice here 12 is 1490, 13 is 1510, so that fell between the two. My final answer fell between 12 and 13. All right, on this side, I decided to switch it up a little bit. We could have made a table for this one as well. I decided to do a picture for this one. We had a car, and that held 10 people. We had 8 buses, and we didn't know how many people those would hold. We had 386 people. So I had 10 people plus 8 times the number of buses, and that needed to be 386. So here, I said 8 buses with however many people I needed to have, and then 10 people would ride separately. And then I found that each bus needed 48 students. Number 5 here, we've got a candy bar and a soda. You have to be careful here. We see the number 3, but if you read this carefully, we see we're buying 4. 4 of each, 4 candy bars, 4 sodas. So again, I decided to draw a picture. We knew how many we had. That's a good time to do a picture. When we know how many of something we have, we're just looking for a cost or value of that. So here are 4 candy bars. Those are question marks because I don't know the cost. Then I had 99-cent sodas. Then here you got to read carefully and notice that there's also a tax added in. That's more realistic, and the total was $9.76. So again here, I can look at this in a few different ways. I want you to start seeing the distributive property when that comes up. I had 4 times the price of my candy bar, 4 times the price of my soda, plus $1.04, needed to be $9.76. I could have also, since I was buying 4 of both of those things, the candy bar and the soda, I could say that if I add the candy bar and soda together, I need that total 4 times. So again, just looking for alternate ways of representing information in terms of algebra. And then when I solve that equation, I didn't show my work here, I get $1.19. So the equation, the picture for that situation. And on this last one, I decided to show work backwards. So right here, remember, work backwards starts at the end of the story. We spent $26. That was the end of the story. We bought a calculator, so I subtracted $5 off of that total to get how much I spent on notebooks. And then I had to divide that into 3 equal portions because I bought 3 notebooks. So this is a work backwards situation using arithmetic. Again, I could have also made a table. This one, the picture's a little more difficult because I don't know how many notebooks to draw. We were looking for the number of notebooks instead of the cost or value of something. So then, if I want to change this to an equation, notice here that what I started with 26, I end with in the equation. I subtracted 5, so I have to add 5, and I divided by 3, so I had to multiply by 3 in my equation. So work backwards just tells us what we had to do to the equation. I had to subtract 5 from both sides to get this. I divided by 3 on both sides to get this. So there is a feedback for the 1.3 practice.